Okay, welcome everybody. This is the fifth Sustainability in Media session of the meet and greet. Janet Greco is behind this initiative, and we're kind of trying to invent the next form of online conferences. This is the first one to address the home network. Just one highline figure so that you kind of see what we're talking about. In France, where I live, 6% of the primary energy of the country is used for digital lives. And I believe the very vast majority of that is initiated within the home, i.e. the home network. Understanding the sustainability of the home network is a big issue when you're looking at the overall picture. Today, we have with us Mike, who will present himself when it's his turn. He's the president of the Broadband Forum. We have Wojtek from Orange, who is the director of CPE ecosystems. And we have Wouter, chief architect of fixed devices at Deutsche Telekom. I'm Ben Schwarz, independent consultant. I will be your moderator. Just a few quick words about what you're going to be hearing about today. Hopefully, we won't agree on everything, so we'll have some debates, but we'll be talking about regulation and carbon footprint. We'll be talking about complexity in the home. We'll be talking about Orange's latest gateway, which was eco-designed. We'll be talking about why you need to measure things end to end and not just concentrate on single devices. We'll be talking about truck roll reduction. We'll be talking about energy efficient Ethernet. We'll be talking about CPU power savings in the home gateway. We'll be talking about how to involve users in the journey. That's the kind of theme that I will try and stick everything together with, and ideas like gamification and how else we can get them involved. We'll be talking about why sometimes a more powerful home network can actually be a good thing when it leads to Wi-Fi offload and it enables things like work from home. Of course, we'll be having audience questions, so please start putting your questions in now, so I will have time to order them and make sure that they all get addressed. There is going to be a follow-on session. This session is a webinar format. It will be followed at 6 p.m. CET by a free-for-all open session, so any questions that don't get addressed in this session will be carried on to the next session. Briefly, before I hand over, just so that you know the order, we're going to start with Mike, who will give us a presentation from the Broadband Forum perspective on this whole issue. Then I will have two quick discussions with first Wojtek from Orange and Wouter from Deutsche Telekom. And then we'll have a panel discussion, and we will end up with addressing Q&A from you guys. So as I said, please start asking those questions now. And without further ado, I'm going to hand over to Mike. And so with all our speakers, if you could start by just giving us a few sentences on who you are, I think you'll do a better job than I will. Over to you, Mike.
Hey, thanks very much, Mike Talbert. I've been in the broadband industry for many years. I am currently the president of the Broadband Forum. I appreciate the opportunity to address the audience today. I'm going to come at this with a little bit of a different perspective. I've got a few slides. So let me show up my content. So again, today we're going to be talking about sustainable broadband. What does that really mean? And, can we involve our subscribers on this journey to a cleaner planet? It's come to my attention that, regulators across the world are looking for a reduction in carbon footprint. I think you heard from Ben this morning in his area, 6% of the carbon footprint is really being spent on broadband, and I'm sure across the world, the number is potentially a little bit higher than that. We see that consumers or subscribers are demanding a higher quality of experience with their broadband connection. They don't care the when, the why, or the how, they just want it to work. When we look at the home and some of the changes that have been happening, the home is starting to become very complex. So when we look at the complexity of the home, we understand that the number of devices that was just a few years ago is now on the upwards of 20 devices average per home, with some homes having 50 to 100 devices. As we look at the complexity, telehealth becoming a very important part of the home recently, work from home being inspired and then pushed aggressively with the global pandemic. Streaming, we've gone from normal QAM-based TV to now streaming TV. Wearables, nothing new here. IoT and again, XR and gaming devices really becoming forefront, that number is continuing to increase. We see Wi-Fi, many years ago in the early 2000s, late 1999, the first Wi-Fi based residential gateway. Now we have quad band devices running 2.4, 5 gigahertz and 6 gigahertz, really supporting the number of devices that are out there inside the home. Our WAN connection, as we look, in the past, fiber, DSL, cable, and then obviously recently with the innovation of 5G, really driving some additional WAN requirements as we look forward. When we talk about power and we step back a number of years to that single band Wi-Fi home router and our power footprint being, roughly about 15 watts plus or minus a little bit, moving forward into dual band Wi-Fi home router. And then now, recently as we step up into tri-band, we're going to rename this as a smart gateway. And then, we're seeing some devices hit the market as 6 gigahertz becomes prevalent, really looking at a quad band gateway to mitigate the need to running wires throughout the home or running fiber or coax, really using Wi-Fi as that backhaul throughout the home, potentially demanding a quad band device. But again, those devices, as we increase the amount of Wi-Fi, obviously power increases. When we look at adding or integrating 5G into our gateway, those power numbers can also jump another 20 to 30 watts. So we understand that there's this contention point where regulators are asking for a more friendly footprint, but the functionality in the devices in the home is growing logarithmically. Recently, we have started over the last couple of years on what we call our services-enabled gateway, where the gateway is now more than just a pipe to provide for internet connectivity. It's really going to be driving services, whether those are services embellished by the end user, things like managed Wi-Fi, health and wellness, telehealth, being able to work from home more effectively with additional VPN services, but also on the order of regulators really wanting to understand what's happening with those customers, and more importantly, the operator mandated to ensure that that customer experience is getting more positive. So as we look at the complexity of the gateway going from just a delivery device to now potentially being part of those managed services, we understand that that gateway needs to be more powerful. Should we in the standards area be looking at ways to really mitigate power usage as we move forward with these services? Should that be part of our specifications as we look at Wi-Fi? Should we be looking at how to really mitigate the power output of Wi-Fi across the board when things are not being used or not being used as heavily? And again, I'll say thank you very much and turn it back over to you, Ben, for some more robust discussion.
Thanks, Mike. The next up, I'm going to have a brief chat with Wojtek. Wojtek, you're in charge of ecosystems around the CPE. And the first question I wanted to ask you is about Orange's new gateway, the Livebox 6, which I don't yet have in my home, but I hope to have soon. Anyway, I know that it's been eco-designed. Do you know if you could tell us a bit what that means, that eco-design, and how it relates to energy efficiency of the device?
Thank you, Ben. Indeed, Orange has this clear goal. We would like to become a net zero carbon company 2040. So it's on all our activities. This is why we are looking on everything, and the Livebox 6 is just one of the examples. So when we are saying that the Livebox 6 was an eco-designed device, basically it means three things. First of all, that it was designed for low energy consumption, of course. But then there is also the fact that it's built from recycled and recyclable materials, both for the casing and packaging. Third element is that it's designed for refurbishing, which means that we want really to reuse as much things as possible. So that's the third axis. Then regarding the energy consumption, I don't know whether the Orange numbers were officially released, but if you are curious, you can find from some web bloggers some measurements. And basically, what they say is that our Livebox 6 gateway has a consumption around 8 watts, but we have two energy savings modes. The first one divides by 2 the nominal energy consumption, and the second one, that is a deep mode, consumes just below a watt. So
deep sleep,
all
mean,
that means, sorry?
Deep sleep, you mean? The deep
Yeah.
mode, you mean deep sleep mode? Is that what we're referring to?
Exactly.
Right.
Exactly. So that's the second one. And basically it means that it gives some energy consumption. So if you look at it at the individual household level, this is maybe not a very huge number at the end, but if you multiply it by the millions of households that we have, you will have a very impressive number. So this is why it's so important, and this is why we invest so much in this area.
So we're talking, you mentioned multiple watts multiplied by roughly 10 million subscribers, potentially, that could end up having this device or future versions of it. So we're talking 10 million times that wattage instantaneously, and then you just put kilowatts divide by 1,000 an hour, and you put the number of hours. So we are talking vast amounts of energy. Okay, so your numbers you were starting at a nominal of 8. I've seen other bloggers say the nominal was 10, but even if that is the case, it's still pretty impressive compared to Mike's figures, who was saying it's 15 up, and we're 10 or below. So we're already like 30% below a typical, and that's without the power saving modes. So yeah, it does seem it's going to be exciting in a year or two when we have enough. When was it? It was launched in 2022 or 2021, the Livebox 6?
2022. It was the beginning of this year, I believe.
Okay, so we'll need at least a year or so to start getting full measurements and to tell, but we are talking a major impact. And before I move on to the next thing, how different is it from the Livebox 5? Is it significantly reduced, or was the Livebox 5 already power efficient?
It was already power efficient, because this is not just for Livebox 6 that we started this approach. However, the new low power modes are different than for the Livebox 5. This is why the overall consumption for Livebox 6 should be lower. But this is not the only thing. Actually, what we did and what we will exploit also in the future is that we are able to measure how much energy a Livebox 6 actually consumes. So we can not only show it to the user, as they can see already now in the applications, how much the gateway consumes depending on the way they leverage the low power modes, the way they use the home network, but it also enables us to further improve the energy management algorithms and to know it's both at an individual gateway level, but also for all of them, all the gateways that are deployed. So we have this feedback from the field that can be really useful for improving the algorithms.
Okay, so you really answered my second question, which was, what are the other things you can do around the Livebox, around sustainability, beyond its pure physical characteristics and energy consumption?
Yeah, but it's not all. Actually,
that
was a kind of things that we already have, but we'll further exploit. But there are also some additional ideas that we have. So, in our RFPs, we already have some energy-related requirements. So this is not a secret to any OEM that is participating in those RFPs. But we don't limit it just to RFPs. Actually, we work with chipset vendors to improve not only the energy consumption, but also the wake-up times. Because when you talk about low power modes, there's always the question of how does it impact the user experience. So we work with the chipset manufacturers on those topics. We also work with the OEMs themselves, because when you see the design of a board, basically a system is composed of several subsystems. And in our approach, when you don't use something at a given time, you should be able to switch it off and to switch it on only when you use it. So it will give even more energy savings. So once again, we work on those topics with OEMs. But our ambitions are not limited to just to ourselves. We really want other operators to follow a similar sustainability path. And this is why we plan, together with the prpl Foundation and the Broadband Forum, to standardize the APIs that will enable to manage those low energy modes, wake up times, and different types of optimizations. So this is what we would like to do in 2023. Then, yeah.
Yeah. So
you wanted to interrupt me?
I understand what you mean. I know what the word API means. I know this kind of API, but what would be a typical use case? What kind of process? So we would be talking to the gateway and say, "Hey, Mr. Gateway, can you please go into low energy mode?" Who would control that? So if it's going to be public, there must be. Have you started thinking about how these things would be orchestrated?
Yeah. So there are two ways of doing those things. One of them is you give some control to the end user. The question is how much control you want to give him. Another one is to try to use some algorithms, and especially algorithms based on artificial intelligence, to leverage those features. Okay, so what you can imagine that those things can be optimized at several levels. So you can individually optimize a gateway or a Wi-Fi extender. That's the most obvious things. But then you need to think about the entire home network composed of several elements, and to think about a whole LAN wake-ups and savings modes. Okay. So the entire system managed in a similar way. Then you can go further and imagine that depending on the current usage and the location of the devices that consume the connectivity, a part of your Wi-Fi network, so some of your extenders, can potentially be switched off or in a low power mode, in other words. So that's another approach. Then you can also think about the way of optimizing your backhaul and fronthaul needs. Actually, you have several Wi-Fi radio bandwidths. You have Ethernet, you can have CPL, MoCA, and other technologies that Mike mentions. So, of course, today everybody thinks about the way of optimizing them to in order to get the best possible throughput, or sometimes latency. But you can also think about doing the optimization just for the sake of energy consumption. Of course, those optimization targets can be mutually contradictory. And then there is a big question, okay, so how to make the choice? But that's most probably another long discussion that we can have.
Yeah, well, perhaps we'll keep that discussion for the panel part of this webinar. I'd love to get some input from all the speakers on how we'll get users to accompany this journey. But just to close off, Wojtek, because we need to move on to Wouter, I'm getting the impression, though, from listening to you, that you're talking about all these multiple parts of the equation. But to understand this, to optimize sustainability, do we need something more holistic, more end-to-end that that will help us move forward?
Yeah, so of course, I was mainly talking about optimizing the energy consumption once the things are already there. Okay, so how you optimize then those things. But if you look at this, you need to keep in mind that you can optimize the things individually, but you also need to have a look at the end-to-end level. What is very interesting is that when you see a gateway that is already built and deployed, it has some amount of resources and does some number of things and consumes some amount of energy. So basically it's a built green footprint, the build stage green footprint is already there. So the more you use it, the better it is. And basically, if you say that, okay, when I have a new feature that I would like to add to such a gateway or for my customers, and you can make the choice between the gateway and the cloud, then you see that if you add this feature in the gateway, it doesn't increase the energy consumption and it doesn't require any new build stage green impact. But if you put it in the cloud, then basically you will need more resources in the cloud and you will need more energy in the cloud. So I'm not saying that you can always do that, because in some cases it just makes no sense to put things, or you just cannot put them in the gateway. But every time it's feasible, you need to think about that the gateway is already there, it's already consuming something, and then you need to make your choices. So the big question here is why today we usually prefer to put features in the cloud. And this is because of the way our gateways are, the software stacks of our gateways are designed. It's really hard to add a new piece of software into the gateway, while it's quite easy to add in the cloud. But this is something that we're also addressing with the prpl Foundation, with the application layer, which basically will enable the prpl-based gateways to be able to get a new piece of software in a simple way, as simple as to add it into the cloud.
I get it. So if I just paraphrase what I've understood, if we take an end-to-end approach, we will realize that the correct localization of some processes or maybe storage isn't always the cloud. Sometimes it makes sense because there's idle time, which maybe we can discuss in the panel too. Idle time, it's the gateway's there, ready to do stuff. If you make it do some simple stuff, it's not going to consume any more power because it's already there and on. So yeah, that's a really interesting.
Exactly.
So thanks, Wojtek. Stay on. We'll pick up in the panel. We must move on because we're running just a few minutes late. Wouter, I wanted to move on to you and start to ask you a few questions. In his opening statement, Mike was just talking about regulation and the importance of the regulator. Perhaps you could just update us on what it is like working with European code of conduct.
Yeah, so so there are multiple standards organizations that will give you a logo if you go through their tests. And there doesn't seem to be a fixed regulation in any particular country to do that. I've worked with operators who've chosen, I'm not specifically representing Deutsche Telekom here, just in my history in the industry. I've worked with multiple operators who've chosen of their own to go through one of these tests. In Germany, the Blaue Engel, the Blue Angel certification is something that we absolutely strive to get. I have more experience in the past with the European Code of Conduct. That's a very realistically and very well-written specification that indicates for every type of interface you add to a CPE or to a gateway, an extra wireless radio, an extra antenna, an extra Ethernet port, etc. We'll go and look at how much does it consume when it's off, when it's not being used, how much does it consume when it's at its maximum usage, at its maximum performance, and how much does it consume under normal situation where it's just getting used occasionally. and sets certain values, and as in the amount of power consumption you can have over each. And that's a very clear specification that you can work technically towards, because you can just put a watt meter, a very fine-grained watt meter behind the gateway, and nicely make the individually test every one of the interfaces in the different modes and see how much does it consume. That's the most important part of that, actually, is that the regulator specifies this in a good way. That didn't always used to be the case. In earlier versions of it was fairly unrealistic, actually. Later editions of the standard became much more detailed. Older editions were really at the point where we, with OEMs, had to scratch our heads and go, we're never going to pass this if we add this extra interface. How can we cheat and move around things to be able to even pass this for our use cases? So the standard also has to be realistic. You want to offer certain functionality, you want to offer new capabilities to your customer, and there's always going to be a power consumption cost that is associated with it. The important thing is that only take that cost if you're actually going to use it.
I want to ask you about truck rolls, and basically, for those not in the industry, that means sending an engineer out to people's homes, which is very costly in terms of energy. And what improvements you're seeing in CPE hardware, in self-diagnosis, analytics, reporting, those things that might work on that, and is it something significant that we should be looking at?
So this is also something that Wojtek pointed out, that you really have to look at the whole picture of any particular piece of functionality that you have, and that includes the life cycle of a device. So there are all sorts of logistics involved in producing a device and shipping it from the country of production towards the consumer. Wojtek also pointed out refurbishment, as in extending the life of the device after the consumer no longer wants the device, and then refurbishing to use it somewhere else. It's significant, the cost in production of the device, so doing that is great. But in between that, there's a big gap, actually, in the sense that it happens very often that a device is at a consumer, and it happens, there can be manufacturing problems, there can be problems that manifest over time as the hardware degrades, through which it is very common to either not know what the problem is. It's not easy to determine these things, apart from typically in the OEM's factory, where they can do post-mortem analysis and take the thing apart. And it's very common for the customer support to say, okay, you know what, ship it back to us, we'll replace it, or to send a technician on site who will take it out, replace it with another device, and see if that solves the problem. Especially if you're going to send a technician out, that's the truck roll. That's energy consumption. That's for the person to go there, etc., and to return. That's very, very significant in terms of energy costs. So what would be nice is if we would be able to determine the health of the device and of the electronics in the device remotely. If the device were to be better aware that, well, what if there's a hardware failure, or what if there's a degradation of one of the components? What if a capacitor is degrading on a wireless antenna, and therefore we are not actually getting the right reach anymore, and the customer is just experiencing lower performance on wireless? There is actually, either we could do something about it and we could do a dynamic recalibration, and that thereby extending the life cycle of the device. That would be great, but at the very least, diagnosing this and reporting this would be great. Other things that typically happen is that if there is a hardware failure, what typically happens is that we don't design for broken hardware. It's very difficult. I always say that if you want to do this, you actually need a plethora of devices with every possible hardware failure into them to make a software development to detect each of these, which is not that easy. You're not going to sell an OEM, please ship me 10 devices that you broke in different ways. So it's very difficult for development to do that, but I think it's a worthwhile effort. What will typically happen as the device starts up and there's some catastrophic failure is that some device driver will crash, the whole device will reboot, the whole device will hang, because we don't design for it. So it's a worthy avenue to explore going forwards in the future.
Okay, thank you. That was a very complete explanation. Wouter, you in our prep discussion, you discussed energy efficient Ethernet, which kind of surely Ethernet doesn't consume anything in the order of things. Why is that a subject you think that's worth mentioning here?
So I actually have a whole list of interfaces. I'm the low-level guy. I'm the programmer. I've been doing these things. So the problem is that there's so every feature that reduces power consumption always has a cost. That may be a cost in performance. That may be a cost in latency, and it may have a cost in interoperability. Wojtek's been talking about how quickly do we wake up from sleep modes. I've been through that. I've been in the situation where putting the CPU into an idle mode when it's not doing anything, or switching it to a lower frequency, has the result that if you're all of a sudden doing a burst of activity, like suddenly launching a speed test, then you have this tiny performance loss at startup. So working with the silicon vendors to fix these things helps to try to still to have the goal of having the low power consumption, but still have the highest performance. Ethernet is one about interoperability. So when we deployed that, actually 802.11, IEEE 802.11 is that an energy efficient Ethernet was about if there's no activity on an Ethernet port, shut it down. We don't need the electronics constantly listening. In the early days of deploying that, we had interoperability issues. There were certain laptops, there were certain Ethernet cards that could not handle this. And there you have customers calling, customers complaining. Should we put a button on the interface that this disables it by default, and then can enable it then? These interoperability problems are the other aspects there.
Okay, so one of the key things is disabling unused Ethernet. The crux of my question was: is it a significant amount of power? I mean, what are we talking about? Milliwatts, presumably.
If you have 4 Ethernet ports and nobody ever plugs anything into them over the whole life cycle of a device, yes, it's going to have a significant. Right. It's going to add up that there is something constantly listening on them versus powering down the PHY, and as EEE does, only probing once per second to see is anybody there.
Okay, let's finish with another power-saving hardware feature. It seems to me that maybe that's where one of the breakthroughs was with the Livebox 6 that Wojtek was talking about, but the actual CPU, the heart of the beast, is one of the most energy-consuming parts of it. And what's going on that front to manage and to obviously reduce the power consumption at the CPU level of a gateway?
So there are multiple aspects to that. The fortunate thing is that we've had the wireless industry. We're using battery-powered devices such as mobile phones has been optimizing on power consumption in a crazy manner just to extend battery life, and we've gained some benefits from this. This is also one of the reasons why a lot of the ARM CPUs have made their ways into the gateways, even though they didn't seem at first to be the optimal architecture, because the ARM has been focusing so heavily because of the mobile world on this. They're not the only ones in the game. There are other instruction set architectures and vendors who've been following that quite nicely. Some of the things that ARM have done, for example, at some point in time, is be able to dynamic frequency scaling is one. I briefly mentioned that. If you're not actively doing anything, how about you just go slower? Slow down your frequency of your processor. You'll do things slower, but you consume less power, because power consumption is a second order of your frequency. Actually, it's all great to have 1.7 gigahertz CPUs, but there's a cost to that. That's not always bad. If you have a very high frequency CPU and you need to do something, you have this sudden burst of activity and you can go back to sleep. Sometimes you have constant activity, and then you just want to be able to handle it at a lower frequency. So it depends. There's some complexity there. Other aspects is one of the things that ARM's done, which I don't think is rippled through too much yet, is that just sleeping altogether. Because the CPU, generally, you can't shut it down to 0 hertz and stop altogether. ARM has at some point in time done this for extremely low power devices where if nothing's happening, just stop. Do nothing, consume 0 power, and then whenever an event happens, and it could be a clock tick or some external event happening in, packet coming in via Ethernet, some interface, you wake up and you immediately start running again. There are things you can do on the software side as well to control that. We generally nowadays we have multiple CPU cores. The ones that aren't being used could be completely shut down and and enabled when your load becomes so high that you really need the extra processors. You also have the and this is a Linux thing actually. Very traditionally, CPUs were running in a way that you have a specific clock tick. Typically, at every 1 millisecond, so 1,000 times per second, you have a clock tick that says, "Okay, now we wake up. Do we need to do anything? Now we wake up. Do we need to do anything?" That ends up being using a lot of power. So there's a tickless mode that was introduced in the Linux kernel, which took a very, very, very long time for the silicon vendors of the gateway chips to adopt, where you say that, don't do this at all. Go to sleep and only wait for external events or for clock events to indicate that now there's a timer that goes off and wake up only then, not every millisecond to see if all of, and go over our timers, or wake up when there's an external event coming in. That's a support of the hardware and a support of the silicon vendor is essential for that, and that really makes a difference as well.
Okay, so we need the silicon vendors around the table next time.
Absolutely, yes.
Okay, so we're already 40 minutes past the hour, so I suggest we move into the panel discussion on some open questions. Before that, I don't know, Wojtek, were you able to see that question from Tommy?
Yeah, so the question is, can Orange Deep Sleep mode be personalized so that users can choose for Wi-Fi connected smart home devices, such as security cameras, not to be deactivated? So right, the deep sleep mode, you can't. The deep sleep mode is really nothing happens, and basically you can wake up the device on some external events only. Okay, so that's the one. But regarding the use case you described, this is a kind of use cases that will be most probably available in the future. When I was talking about this, improving the energy management algorithms, this is a part of those. So yes, in the future, this kind of things will be possible, maybe on with a little bit different approach, but basically to take into account what can happen will be of importance in these algorithms.
Okay, thanks for that clear answer. So moving on, I want to take all three of you slightly out of your comfort zones. You're all relatively deep tech guys, and I want to talk to you about marketing, about the end user, and get your perspective. I always think it's interesting to think what people's ideas who are not core marketeers about marketing. Getting marketeers to talk about technology is less interesting, but that's for another discussion. So marketing, gaming. So I came up with this idea. Could it be gamification? Do we want a green button? All three of you came up in your presentations about issues with the end user. Will they accept it? Who wants to take this first to say, well, how, as an industry, ISP industry, let's say, you know, how do we actually get the users involved? Because from what all of you said, there is going to be an impact. So first, if you want to comment on what kind of impact a more sustainable homeland would have on user experience, and to what's your vision of how users might get involved. Mike, you seem to be ready to talk.
Yeah, thanks very much, Ben. So speaking from the U.S. point of view, and I'll stay away from the European point of view. From the U.S. point of view, the end user, the subscriber today is, they don't care about, you know, having to touch things. They just want it to work. It needs to be there when they want it, how they want it. It needs to be expeditious. It needs to be fast. That's why I believe that there's a bunch of work to do in the standards area where we can specify methods to go into, I wouldn't call it a deep sleep, but something in between, so that we have, you know, connectivity across our devices, so that if a security camera saw something, it could send a picture in. If a glass sensor detected something, it wouldn't be talking to a gateway that was in deep sleep and was not listening. That's where I think we have some work to do there. I think Wouter had a very good comment. You know, we have these multiple core ARM processors. You know, if they're not being used heavily, let's shut those cores down and really go into a minimal energy mode so that we can keep track on things that are going on inside the home. The telemedicine, I mean, if you can imagine you have a sensor on your arm that's telling about insulin numbers and it's not communicating to your gateway so you don't get your shot, causing a medical condition, those types of issues are very impacted to customer experience. How do we deal with that, yet still be compliant with what the regulators are looking to do as the complexity of the home moves forward? I think those are some big challenges out there.
So if I hear you, you're saying the bulk of US consumers aren't interested as we speak today on embarking on this journey. And if they were to, we would still have to absolutely assure some essential services. So the deep sleep modes we've been talking about have to evolve to manage security cameras, medical devices.
If we can make it transparent to the, end user, that would be the best win. But however, then, you know, at some point in time, they do need to be cognizant of energy.
Both Wojtek and Wouter are based in Europe, and my understanding of the European consumers is they're basically three categories. There's a small category, just like the Americans you discussed, that basically don't want to know. They want the best service for the least money. We'll always have some of those. And I believe they're in a quite small minority right now in Europe. Then you have another small minority of about the same size, maybe 20, 30%, who will embrace any kind of thing we give them. They'll press all the green buttons and they'll accept, slower streaming time or whatever. But there's the vast majority, and that may be different from the US, I think, in most European markets, who are kind of, well, maybe tell me about it. What is this green stuff you have? Is it actually going to make an impact? Is it going to have a small impact on my use? And will it impact so I don't know, Wouter or Wojtek, if you want to take on the challenge of answering Mike, do you see different kind of perspective of talking to consumers about this?
Yeah, I already mentioned it. In the Livebox 6 case, we have a smartphone app that actually provides you what is the consumption of your gateway, and it depends on what you actually do and what are the low energy modes that are used, etc. So this is the first stage, because the user is aware of it means, because basically I agree with the analysis you make, Ben, that are different consumers. It's not such a thing as the consumer that we can define what he wants. There will be always very different consumers, and the big question is in which way we can address all of them. So think that we will be able, at least in a reasonable future, to have something that is that provides a very low energy consumption, at the same time has no impact at all at the user experience. There will be something that will need to be put into the balance. Okay, so my way of thinking about it is the following: you can optimize those different things, but the user experience will be different. So my personal way of feeling is that if you explain to the end user that he can make its choice regarding the impact that he will feel, then he make the choice, and to see also the feedback, what his choice made as a result. Okay, if there is no feedback, on the savings, I mean, if he only sees the negative part, which is, his user experience is worse, but no feedback on what were the savings, it will not work. So in our way of thinking, we see that you need both. You let the end user to make some choices, to accept what is the user experience price he's ready to pay, but at the same time, you show him what is the savings that it brings.
So you're translating the savings, which luckily in this case we can do, directly into money. And so the very first step is what Orange has done.
Maybe less money.
Well, because with
less
the energy
about
prices,
money.
we don't know when Putin's war is going to be over, and for now, energy is just
agree,
going up and up and up, and so
I know, Ben. But you must, this is what I said at the beginning. If you look at how much those gateways consume right now, it's not that much. So even if you make some optimization of 30%, at the end, during the entire year, it will be a few euros, maybe 10, maybe 20. Okay, this is not a very huge amount of money for an individual household. It's only when you multiply it by 10 millions that you see a huge impact on the geopolitics and all this stuff. Okay, so what I believe is not so much that it's about the money that you need to communicate to the end user, but the energy savings. Okay, something that he feels better because he knows that's important, whatever the money it costs.
Okay, that's an interesting point. And Wouter, do you have any comments on this, trying to get users involved?
Sure. So yeah, in terms of gamification, well, that's what our electricity providers are doing to us by making it really, really expensive. So the points are indeed money. I recently have the ability here at home to measure in fine-grained detail what sort of power consumption that I have in real time. And yeah, Wojtek is absolutely right. The big energy consumers are if I plug in my car to charge the battery, if I switch on an oven or switch on a water cooker, an electric water cooker, that's thousands of watts right away. And but they're usually short-lived, apart from charging the car. If I compare that with the base load of all the electronic devices, and there are a lot in my home, it's very small. However, if that base load is always there. So if as a user you do want to improve your power consumption, reducing that by a few percentages because it's constantly running will actually make a difference. So yes, providing the feedback, and that's the key point there, providing the feedback to the user that on this particular device you were able to save so many watts on average consumption really matters, and people will start looking at it, at least some people. The better case, I would say, and Mike said that the ideals, talked about a certain ideal scenario. My ideal scenario is that we manage to make devices that always use the least amount of power possible without sacrificing user experience. If we can push the hardware and the software towards that, that's when we really made a difference.
We could aim for a world where the negative impact would be negligible, so we wouldn't have to have this big debate. If we say, well, actually, a really powerful home network, which incidentally may use more power, I don't know, but powerful as in lots of features, an intelligent network will be better for the overall would be better for the planet, because it will encourage work from home, because it'll have all the power to provide all the tools for people to work from home. It will be much better at Wi-Fi offload, so a lot more traffic will be coming end up going through the fiber rather than going through other ways and stuff like that. So if anyone wants to take a dig at that question, a more powerful homeland as actually a good thing for the planet.
I think that's a very important question to consider. As we look at the pandemic hit, we saw our freeways and our highways dispopulated with automobiles. Obviously, a significant impact into the carbon footprint. However, the impact is now I am at home, my power usage is increasing at home, my Wi-Fi usage is increasing, my network usage is increasing. I'm home all the time, which means I need to have my hot water heater on more, my heater is on more. So we have this displacement from the industry into the home that's actually driving additional consumption in the home. The consumer now being co-located in the home is looking for these additional features to make their life easier. So when we look at total cost of ownership or total cost of carbon footprint, really moving the energy into the home, is that positive for the planet, or is it negative? And I think that's a bigger question. But again, my position is since we see that coming, shouldn't we be pushing the chipset providers to drive towards thinner silicon to reduce that power consumption? To Wouter's point, if we don't impact the consumer experience and we can do it in the background, it's a win-win for both sides. When we look at our automobiles, we all want gasoline to be cheaper. We move to electric cars, but we've offset the load from a gasoline station to the home.
Right.
You know, so this is an excellent argument, and I really believe that we need to really drive this as innocuously to the consumer as possible to help them out.
Okay, thank you for that contribution.
Yeah.
Then, well, yeah.
If
Quickly,
I
then,
may
Wojtek,
add
we
some
have one
comment
Yeah.
regarding the idea that ideally the user should be even not aware of the optimization that we are doing, etc. I agree. For some use cases, it's definitely what we need to do, and it should be possible to do. But just look at this. Imagine that we promise to the user, and this is the way he measures his experience, is the download time for something, a movie or a firmware upgrade, etc. Okay, so it can take 10 seconds or maybe 1 minute, depending on the way we optimize our whole network. We can do both. And in one case, as it can last 10 minutes maybe, or etc., we will consume more energy, and another one maybe will consume less energy, but his experience will be impacted. So this is not something that you can optimize in general. It's just about what the user considers as important, whether some longer time is acceptable because there is some energy saving or not. There's no single answer. It's every user that can answer this question.
Thanks. Thanks. That wraps up on the first. Can we just address that last question in the chat, because then we'll have to wrap up. So it's another question from Tommy. Basically, he asks, must operators relinquish Wi-Fi as the smart home network of choice in place of low power IoT protocols in order for deep sleep modes to become ubiquitous? P.S. Does DT have an equivalent? So that Wouter, if Deutsche Telekom has an equivalent deep sleep, and in general, if anybody wants to take that question, is Wi-Fi actually threatened because low powered IoT protocols might actually make more sense in a deep sleep environment?
One of the arguments for the high power network is that if you have very fast Wi-Fi in the home and you have a good fixed line connection, the amount of energy you consume to send up a bit over to the internet is actually orders of magnitude lower than if you were to use cellular. So I think Wi-Fi is actually in the home is a good thing for low power consumption, and it's better to focus on making sure that becomes more efficient with new evolutions of the standard, such as 802.11 BA, I think it's called, then try to move away from that. So when it comes to IoT protocols, right, sure. So if you have a device that is entirely battery powered, I have, for example, some IoT devices. One of them is a smoke sensor, which has a battery, which lasts a couple of years. You don't want those on. You're on mute.
You need to wrap up in the next 30 seconds if you can.
Okay, right. So IoT is for IoT devices. Anything that you need to transfer some information over Wi-Fi or Ethernet are your best options. Yep.
Thank you. Excellent. The short version was really clear and a perfect answer. So, guys, we've finished. We're wrapping up now. So there is an open discussion. So I hope the three of you can join us for the next hour. And this will be a different format. The room doesn't work quite the same way because everybody can join in, and it's an open discussion with everybody, and we'll carry this forward. So you just need to go back to the main navigation, click on program, and join the next session, which will be interactive conversation. Hope to see you there shortly. Bye all.
Thank you.